Welcome to video 3.4b, another proof with medians. All right, this is example 2. Let's take a look at it. So, we're given that FC is the median of triangle FBD. So it gets kind of confusing here. Triangle FBD is this green triangle right here. And if FC is the median, that means it divides the opposite side of the green triangle into two congruent parts. So I will be able to get that part to be congruent to that part using the definition of median. Okay, so it's not given, but I'll get it right from there. They give me that AB is congruent to DE, so that's this outer chunk here to this outer chunk there. And they give me angle FCB. FCB is this angle. You can't assume it's a right angle just because it looks like it. So that angle is congruent to this angle here. I like to put my arcs offset so it doesn't look like one big arc. Okay, so that's all the markings. I'm trying to prove that FC bisects angle AFE. That's the big angle. So what I'm going to try to do is get this angle here to be congruent to that angle there. That one there, and that one there. Okay, so again, AFE is that big angle. All right, well, so this is the hard part. Which triangles you want to get congruent? Well, since I want to get these two big angles there, I'm looking at big triangle on the left to be congruent to big triangle on the right. So I'll just outline those in blue. And I guess I'll do the other one kind of in bold black. So those are the two triangles I'm trying to get congruent. The big left one and the big right one. Okay, well, let's see how I can go about doing that. Hey, they share this side here, so that would be reflexive. That would be a side. Oh, they gave me that angle and that angle, so I've got a side and an angle. If only I had this side to this side. Well, they didn't quite give it to me, but they almost did. So by the median, I got those two segments congruent. They gave me those two segments congruent. So how can I get this segment here congruent to that segment there? You may have guessed it, segment addition. Okay, so now that I kind of have an idea for what's going on, let's go ahead and do the proof. So in this case, I'm given a median and using that information. In the last proof, I was trying to prove that we were a median. All right, so again, I'm going to try to go in SAS order. So I'll start with this side here. So I'll say FC is congruent to FC by reflexive. And I'll get credit for a side there. I'll then go the angle. Angle FCB is congruent to angle FCD. That was given. So I'll get angle credit there. Now I'm going to work on the sides. So I'll use that definition of the median. So I'll use this. FC is a median of triangle FBD. That was given. From that, I'll get BC to DC. So BC is congruent to DC. So if median, then I get that stuff to happen. So if median, then opposite side divided into two congruent segments. Hopefully that'll be on. Okay, then I'll use the given. AB was congruent to DE. That was given. And now I will combine those two steps and get the segments that I need for SAS. So now I'm going to say segment AC is congruent to segment, I guess I'll call it EC. If congruent segments added two congruent segments, then the sums are congruent. Make sure you use the correct word, segments versus angles, and added versus some other word. Okay, so that's the S. I'll get the triangles, I'll get the parts, I'll get beyond CPCTC. All right, so now triangle. I'm trying to get these angles here. Sometimes what I do is I'll label my triangle such that it matches that angle I'm looking for. Let me show you. So I'll call it triangle AFC. Once I say AFC, I'm stuck with EFC. And that would be by SAS. Then I can get the angles. Angle AFC is congruent to angle EFC by CPCTC. Okay, and then once these two angles are congruent, I know that I've got an angle bisector. So FC bisects angle AFE if a segment divides an angle into two congruent angles, then angle bisector. Whew. So there you have it. Another proof dealing with medians beyond CPCTC.